In previous video we had understand the meaning of the similar figures. Here in this video, what is the meaning of the similar figures we discussed in detail, and now here we're going to discuss what is the meaning of similarity in polygons, or when I can say that one polygon is going to similar with another polygon. What are that conditions? I told that at last that I'm going to tell you the two conditions of the similarity of the polygons. So similarity word is familiar with now with us, but polygons, though you have learned in the childhood, again I'm just want to tell you, poly means multiple, guns means angles. So those figures which has multiple angles, multiple angles means definitely they have the multiple sides, means many sides, minimum three sides, and if more than three sides, like such a geometry figure which has minimum three or more than three sides and is a closed figure, then such figure is called polygons. Polygons like closed should be that something like, this is a pentagon, or you can see a triangle, anything, or a decagon, hexagon, heptagon, whatever you say, octagon, so these all are polygons. Now when I can say that one polygon is similar to another polygon, and I told you at last that there are two conditions. So one more time, now I'm going to write now the similarity conditions. So first similarity conditions is, if we have the two figures, if two polygons we do have, then their corresponding angles should be equal. And second condition we have, their corresponding side lengths should be proportional. Their corresponding sides. So here now these two words, corresponding angles, and corresponding side, these two words in two conditions might be freaking you. So let me tell you, let me make you clear of these words. What is corresponding angles and corresponding side? Like in previous video, when I was talking about these two squares, see here we had a square PQRS, another square we had P dash, Q dash, R dash and S dash. Here if I'm saying P angle, and if you compare this both square, like, if you're going to put this square inside this, it will be something like this. So now this will be P, this will be Q, this will be R, this will be S. Now see, if you compare this both, the PQRS and P dash QS RS exactly at one time, then it will be, see, P is corresponding to the P dash, means P is respective to P dash, and Q is respect to Q dash, and R is respective to R dash, and S is respect to S dash. So here angle P and angle P dash are called corresponding angles. Alright, these are called corresponding angle. So similarly, if you see this, this is going to match with each other, so you can say that this Q dash and Q both are corresponding angle. Here also, like this angle R and angle this R dash, both are corresponding angle, and here angle S and angle S dash are corresponding angle. Similarly, now if you talk about the corresponding sides, then this side, this PS side is respective to this P dash S dash. So this, this is just facing towards this. So you can say now PS and P dash S dash are corresponding sides. Similarly here, if you see, about the PQ, right, side PQ is, is you can compare that with the P dash QS. So that's P dash QS and PQ are corresponding sides. Similarly here QR, side QR, this your side QR and Q dash R dash, both you can compare. So these are corresponding sides. Here SR side SR and side S dash R dash, these two you can compare. So these are called corresponding sides. Alright, I hope you understand it. Something I just want to tell you one more. Suppose you have a triangle something like this. Okay, alright, this is a bigger triangle, and similarly you have another triangle something like this. Okay, now if you compare this two, how you can say which are the corresponding parts? I'm just giving you the name here. Suppose this is not AB, not P, I'm giving here. This time I'm going to give A, B and C. If you look, suppose if they are similar polygons, suppose, okay, what are the conditions will come later, but I'm just talking about the corresponding. So then, if you match them properly, then this part, this part looks like angle A. Alright, and this is the biggest side, right? See, this is the biggest side, and here biggest side is, BC, and the biggest point is C. So I need to give this C dash, right? Very close to A is B. So see, the biggest side here is BC. Alright, so that is why I give here this side B dash C dash, because this is the biggest side. And after that, the second biggest one is AC, right? This is second biggest one. So that is why I'm giving this this part as a dash C dash. So this is my A dash C dash. And now if you see here, this is the smallest one. AB is the smallest one. So here see, A dash B dash is the smallest one. So so whatever the color is matching here, now see, this AB is going to match with A dash B dash. And similarly, if you look that B dash C dash, this B dash C dash is yellow color, right, which is the biggest one, so which is going to here match with BC. So the BC is the corresponding side of the B dash C dash. Similarly, if you look here, this pink color AC is going to match or looks like this A dash C dash. So that is why these are corresponding sides. So AC is corresponding to corresponding sides to A dash C dash. Alright, and similarly here if you see AB is going to correspond with A dash B dash, A dash B dash. Alright, this part. And similarly here BC, this BC corresponds with, yes, with this B dash C dash. So I hope you understand what is corresponding sides. If you're gonna just match one with another, like if you similarly here, like if you had if you have made this A dash B dash C dash inside this, it looks something like this. It will look something like this, and this will be your A dash, right, and this will be your B dash, and this will be your C dash. Now match it. You can understand what I mean to say. Now this AB is this one. That's why, see, AB is corresponding, A is A and A dash is corresponding, B dash and B is corresponding, and C dash and C is corresponding. So I hope you understand it. And similarly now, so now I can easily say, now this is angle A. Angle A is corresponding to their next angle, that is A angle dash. And similarly angle B is corresponding to angle B dash, right? So this angle and this angle here, or you can say this one and this one, and C and C dash. Alright, means this angle and this angle. Now see, if the figures are like inside one figure, you have a figure, inside that you have the corresponding figure, that becomes easy. But if the figures are completely differently given, like one figure is here, another figure is here, then you need to imagine in your brain, what is going to get matched. Like when you put smaller figure into that bigger figure, like you're going to completely match one figure with another figure, right? Then how it will look. So that time you need to know how is the corresponding angles and corresponding sides. If you understand this, let's go to the conditions. Corresponding angles. So corresponding angles should be equal. The first condition they are saying, like if you have the two like here also, like if these two figures are going to get similar, then their angles should be equal. Means this angle A, this angle A should be equal with angle A dash, and angle B should be equal with B dash, and angle C should be equal with C dash. It should be like that. But this is the case of triangle. Again, I'm telling you, in the case of triangle, just in the case of triangle, if any of these two, we have two conditions. If one condition is satisfied, then automatically second condition gets satisfied. In a triangle, just in the triangle I'm telling, not in other polygons, just in the case of triangle, if the angles are the corresponding angles are equal, then sides will be automatically proportional. I mean to say, this AC over A dash C dash and AB over A dash B dash and BC over B dash C dash, they are proportional. What is the meaning of proportional? Another word also, this can make you twisted. So this meaning of proportional, is something like this. Like here you have like AB. Okay, let me give the size of the AB is suppose 2 centimeter. If they are proportional, okay, if they are proportional, what will happen? If the size of AB is suppose 2 centimeter, so size of AB looks, A dash B dash is 2 centimeter, so size of AB, let me suppose it is something like you can say this is 3 centimeter, or you can say, okay, I'm giving you 4 centimeter. Alright, now see here, and now I get BC. Side BC is how much? Let me suppose this is 5 centimeter. Size of B dash C dash is 5 centimeter. So here size of B dash C dash, if they are proportional, then see, this is AB is 2, so it is 4. So if it is 5, then it should be 10, right? It should be 10 centimeter. Similarly, here a dash c dash is suppose 3 centimeter. Suppose, okay, 3 centimeter. Then here AC should be 6 centimeter. Then only you're gonna have the same proportion. Here, like AC is how much? Like 6 we have, and a dash c dash. No, sorry. Uh, 6 and a dash c dash is you're going to get here 3, right? Similarly here AB is how much? Here AB is your 4, but a dash b dash is how much? 2, right? Similarly here BC is how much? 10, and b dash c dash is how much? 5. So if you cut, what you'll get? Everywhere you'll get like 1 by 2, let's cut all them. 3 times 2, 2 times 2, 5 times 2 means everywhere you'll get like 2 equals 2 equals to 2. So what's your ratio of cutting? 2 ratio 1. Like if this figure, like this figure is just double of this smaller figures. So what is the ratio of the sides? So all the sides, all the sides of this figure ABC of this triangle is double of the all sides of the triangle, smaller triangle A dash B dash C dash. So that is the meaning of proportional. Means in certain ratio another figure is bigger, or in certain ratio another figure is smaller. Try to understand. Like being proportional means another figure, two figures you have, figure A you have and figure B you have, then it means like either A is certain ratio, certain times bigger than B, or in the, depending on the situation, sometime maybe B is certain time bigger than the another figure A, right? Let me give you one more example. Suppose I have this pentagon, right? And I have one more pentagon. Suppose I measured and I got, suppose this is 1 centimeter, but I got this 5 centimeter. This is a regular, so all sides are, here 5 centimeter. This will be also 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 5 centimeter. Since these are regular pentagon, so in pentagon each angles are, yes, 108 degree. So this angle will be also 108 degree. Here also, since they are regular, so each and every angles are 108 degree. Each and every, all angles are 108 degree. Means first condition, they are satisfying that all the angles are equal, right? All the corresponding angles are equal. Now see here, this is A, B, C, D, E. Since this is regular, so you don't have any problem, this is A dash, B dash, C dash, D dash, and E dash, right? So here I was talking like ratio. What is the ratio? Now see, if you see, if the two triangles is similar, then what happens? Their ratio should, their sides should be in proportion. In proportion means in some ratio. It means like if you do like AB over A dash B dash, then you should give the same proportion, you should get the same ratio when you will do with the BC over B dash C dash, and you should get the same when you will do with the CD over C dash D dash, and you should get again same when you will do with the DE over D dash E dash, and you'll get the same again when you will do with AE over A dash E dash. And in all, this all ratio should be same ratio you should get, right? Since this is 1 centimeter, this is 1 centimeter, right? This is 5 centimeters. So here what you'll get, AB is 1 centimeter, but your A dash B dash is 5 centimeter, right? Similarly, here BC is also how much? BC is like 1 centimeter, and this B dash C dash is 5 centimeter. Everywhere you'll get the same, same 1 over 5 you'll get everywhere. Then you can say like this my triangle A dash B dash C dash, not triangle, this pentagon is 5 times bigger as the A B C D E, right? So my figure, this figure, or you can say this my figure is 5 times smaller than this figure. So you can say now these are proportional since their sides are, in some ratio. That is why you can say. One more example I want to give you for the proportionality. Suppose, and this is the last one. I talk a lot about, I think you might get bored. Something, this triangle you have, all right? Now I'm giving the different actually shape, so that's why it's bigger. Let me give it smaller a little. Okay, now see here, suppose this is 2 centimeter, this is 3 centimeter, and this is 4 centimeter. So now I'm supposing like this is 1 centimeter, right? This is 1.5 centimeter, and this is 2 centimeter. So now can you say these are proportional? Yes, the triangles are proportional. If you give the name like this is A, B, C, and let me give you a P, Q, R, two figures you have, and if you compare each other, then it looks like AB and PQ is going to match. You need to, like, when you imagine in mind, then you just try to keep this inside this bigger triangle, something like this. Well, I cannot go inside your brain and do, but try to think like this. When you put inside this, then they will get completely matched up. They will try to get completely matched up with one another. So if they are going to match up in this way completely, then corresponding sides are, this AB is going to correspond with PQ. So AB is actually the corresponding sides of the PQ, and similarly this is your QR. So this BC side, side BC is going to correspond with the side QR. Similarly here, if you see AC, this AC is going to correspond with the PR. And if you talk about the angle, then angle A is corresponding with the angle P, alright, and angle B is corresponding with the angle Q, and angle C is corresponding with the angle R, right? So here angles are equal, because I have already said, like, if they are two triangles, if these two triangles are corresponding, alright, I mean they are similar, then their sides should be corresponding, their corresponding sides should be proportional. So what I mean that here, if you do AB this over PQ, right, and BC over QR, and similarly like AC over PR, then you should have the same ratio, some constant ratio like m over n, a constant ratio you should get in everywhere. Like this is your 2 centimeter, right? AB is 2 centimeter, but if you see PQ, this is 1 centimeter. All right, and if you do here BC is 4 centimeter, so that is why you have QR has 2, and here AC is how much? 3, and here you have 1.5. See everywhere what you're getting, 2:1 you're going to get 1 2 2 2 1.5 2, 1 times 2, you got it, right? As next thing, what I want to say, like, it is not necessary, right? Like first write bigger ratio and then write the smaller ratio. Like first, in the first rows, if you see, these are from this triangle, and in second row just below this, if you see, these are from the smaller triangle. There is no necessary to write in this way. Like if you want to write this first one, then you can write, there is no problem. Like you can write first PQ, first you can write PQ, and then you can write AB. And if you're writing now, next one is PR, then next one you can write AC. All right, there is no problem, you can write in any ways. Now QR, then it should be, if it is QR, then it should be BC. But now ratio will be also changed, like it was m over n, now you'll get n over m, and which is again constant, and that now you're getting, initially you're getting 2 over 1, and now you'll be getting 1 over 2. That's not the problem. Okay, you can write in any ways. First you can, if you want to write first this, right, if you want to write this first, right, no problem. Like if you want to make this numerator, make, nobody will say, and make it denominator. But if you want to make like this numerator, then again make it this numerator. There is no problem. Every time, you'll get the constant ratio. That is what means the proportionality. All right, and you should get always constant. And well, I think you understand it. Or let me give by increasing some numbers. Suppose this is 1.5. In the place of 1.5, if it was 15, okay, if it was 15, if it was 20, and if it was suppose 10, right, if it was 10, so what will be the corresponding parts of this? Now you can predict it. If it is 15, and we have the ratio, like 1 over 2. So if the side of the PR is 1, then the side of the corresponding AC should be how much? Double of this, double of this. Means, I mean, if see, I said PR is, if PR is 1, then AC is double of this. So if PR is 15, then AC should be 30. Alright, this is called corresponding. Now QR is 20. You see QR is 20, means if QR is 1, BC should be 2. So if QR is 20, so BC must be 40. So how much you'll get? This will be 40. Similarly, if PQ is 10, if PQ is 10, see, if PQ is 1, then AB should be 2. So if PQ is, if PQ is 10, so this should be 20. That's it. This is called what a proportionality. I hope you understand what is proportionality and what is corresponding angles and corresponding sides. Now come to our rules. Our rules was to I completely vanished away from the rules. Well, so to be a two figures, corresponding, we have two conditions. So their corresponding angles should be equal and their corresponding side lengths should be proportional, right? And for the triangles, any one is enough, because if in a triangle, if you're getting angles equal, then automatically sides get proportional, just in the case of triangle. And if the side if the sides are proportional, triangles angles automatically get equal, just in the case of this. But in the if you talk about other polygons, like if you talk about hexagon, octagon, right? If you talk about pentagon, then each and every sides you have to measure, and you have to see whether they are proportional or not. All right, so we'll be meeting the next video. I hope you got good concept of this. We'll be doing a couple of exercises, and then we'll jump for the now conditions of similarity in triangles. So from that video, you should be careful. Okay, catch you in the next video. Goodbye.